Okay.
We decided to analyze a common household flashlight.
So a flashlight is like a cylinder kind of shape, right? You flip a switch, and it completes a circuit, it turns on the lights. This particular one takes like D batteries, and its product life cycle is not that long for this one, because I think I broke like 2 or 3 just by using them normally.
These are the pictures of the various components taken apart. There are quite a few of them, and most of them just serve basic functions of holding it together. And then all the metal parts conduct electricity of some sort.
These are some sketches. This one is of the chassis, right? This large plastic part holds all the other parts in, holds the switch, and it has a threaded top so that it can hold the light bulb and stuff in.
These are some of the interior components that make up the actual lamp part. So the lens is just a clear piece of plastic that goes on top and protects the light bulb from getting hit by any debris. The light bulb is what actually produces light when supplied with electricity. Then there's a device on the bottom that actually functions as a clamp on the bottom of the lamp that holds the light bulb in place so it doesn't jiggle around. And then there's a black cap on the very top that screws all of it together and holds it in. And then there is a funnel-shaped device that functions as a reflector for light that is shining backwards so that all the light is actually focused out through the top.
So these are sketches of the switch mechanisms. So there is a long, thin sheet of metal that's connected to the switch. And when you press it, it'll raise the spring that rests in the bottom of the flashlight, which pushes up the D batteries and completes the circuit that the light bulb needs.
So this is the first part. The function of this one was actually a mystery until we had to put the flashlight back together. What it actually does is it holds the light bulb goes in between the reflector lamp and this device, and it holds the light bulb in place so that it doesn't pop up through the lamp or fall down into the flashlight. This is our model of an inventor. It was kind of annoying because it has a little ridge here, around here, where it dips down, and it was difficult to find out what the exact curvature of that was because it's not the radius of a circle. Using the dimensions from that, the eye properties that I got on that is a volume of 0.044 centimeters cubed. The mass was 3.63 grams, and then the density was about 82 grams per centimeter cubed. And so the test for this, it does conduct electricity. It is quite magnetic, but we have no idea how that works. Its hardness, it was able to be scratched, but just the surface of it was. It was bendy, but you couldn't actually snap it. It only bent a certain amount. And then through displacement and a scale, we found the mass to be 3.8 grams, 0.44 centimeters cubed, and then a density of about 80 grams per centimeter with an area of 5.74. And using that, we figured out that it was more than likely made of stainless steel.
That matched up pretty good, right? Your eye
Yeah.
properties. So.
Okay. So then we also did this little plastic piece. It acts almost kind of like a screw or a cap to hold all this stuff together. The mass is about 1.8 grams. Volume is 1.8 cube centimeters. The density is a little under 1 gram per centimeter squared. It's made of plastic. Since it's plastic, it does not conduct electricity. It's not magnetic. It is scratchable. It doesn't bend much because it's pretty well made. You know. Yeah. So the plastic that this part is made of is likely made from oil that comes from Saudi Arabia. Yeah, this particular flashlight says Indonesia, so I'm going to assume that the plastic was made in Indonesia too. Could have been China though. Stainless steel is made from iron and carbon, and most of the world's stainless steel comes from China. Then the light bulb itself is made with glass, let's say steel, and then probably a tungsten filament that inducts when electricity. Is that right?
Yeah.
Yeah, when electricity is exposed to it, probably comes from China.
So this is how the different parts are made. So injection molding is a process where essentially two pieces are pressed together and then the plastic forms beneath that to form the actual shape. And then die stamping, metal sheets are put through a stamp and then they get pressed through to actually maintain their form and create the edge. Its recyclability. All the plastic components are recyclable. They can be reformed and recolored and are typically in these cases. However, most people just throw them away anyway. The metal components, the spring, the metal strip, they can all be melted down and reformed. The light bulb is not, however, because often they contain gases inside, and the tungsten filament and the complexity of the components makes them no longer cost efficient to try and recycle. That's it.
All right. Very nice job. Really good.